So in this class, I want to quickly teach you another formula that you can use to differentiate logarithmic function, that is derivative of logarithmic function, but in this case it's formula, it's more of like a shortcut. So from what we have here now, if y is equal to log function of x, so then the formula says that the y dx will be equal to f prime of x over f of x. F prime of x over f of x. That is, if y is equal to log f of x, then the y dx is equal to f prime of x over f of x. The meaning of this is that if you have y to be equal to what? Log x, right? So then the formula says that the y dx is equal to, what's our f of x here? It's simply the x. So then the formula says that the y dx should be equal to f prime of x, that is differentiate x, which is 1 all over f of x, which is what? X. So that's why you can see that the y dx is 1 over x, the same thing as how we learned it in the other method. So this come handy because while you're differentiating some other functions, you can quickly use this. The meaning of this is that if you have y is equal to, say, log x squared, so from here now our f of x is what? X squared. So then from there f of x is what? X squared. So this implies that the y dx will be equal to f prime of x, that this differentiates x squared, which is what? 2x over f of x, which is what? X squared. And that will be equal to x cancel x, so you have 2 all over x. 2 all over x. So that is from what you have here now. Derivative of f of x is equal to f prime of x over f of x. So you can always apply this. Say if y is equal to log 2x cubed plus 4. So in this case now, our f of x is equal to what? 2x cubed plus 4. F of x equals 2x cubed plus 4. So then using that formula, the y dx will be equal to f prime of x, that is, you differentiate this f of x. So derivative of this, use polynomial rule to differentiate this. 3 times 2, that's 6, x raised to power 3 minus 1 plus derivative of 4, 0. That's f prime of x all over f of x. F of x is equal to what? 2x cubed plus 4. That's equals to 6x raised to power 3 minus 1, that's 2. That's 6x squared plus 0, which is 6x squared, over 2x cubed plus 4. So from here now, you know you can factorize out 2. So if you factorize 2, then you have here, you're going to have 3x squared all over 2 into bracket x cubed plus 2. So 2 cancel out 2. So then implies from here now, the y dx will be equal to what? 3x squared all over x cubed plus 2. That's the derivative of that. You can always apply this formula to any form of trig function, even if you have the argument to be trigonometry, or it's polynomial, or it's any form of like functions that you have as the argument with logarithmic functions. You can always apply this. Let's solve one more question on that. Say you have y equals to log, say, sine 2x, right? Log sine 2x. So in this case now, f of x is equal to what? Sine 2x, right? Sine 2x. So that implies the y dx will be equal to f prime of it. You differentiate this sine 2x. Derivative of sine 2x, remember, you're going to use the chain rule. First, you differentiate with respect to the whole sine. And the derivative of sine is what? Cos. So that means the derivative of sine 2x will be equal to what? Cos 2x multiplied by differentiate. You now differentiate the angle. The derivative of 2x is equal to what? 2, right? Over f of x. F of x is what? Sine 2x. So that means this will be equal to 2 cos 2x over what? sine 2x. So cos x over sine x is equals to what? Cot x. So that means cos 2x over sine 2x will be equals to what? Cot 2x. This is 2 cot 2x. 2 cot 2x. So that is the derivative of that. So you can always apply this formula to any form of logarithmic function. So I hope you've learned something from this. So this is where we're going to stop in this class. I'll see you in the next class. If you haven't subscribed to this channel, don't forget to subscribe. So I drop math tutorial every day, 5 p.m. West African time every day. I'll see you in the next class.